afternoon. This is the demo flight in my own simulator for the A320 demo at the Tu Darmstadt. Aviation Safe Avionics Systems is the name of the course, and I will demonstrate today what we will do in the simulator. So basically I'm operating my own simulator here. It's a Prepper 3D by Lockheed Martin with an FSL A320 as an add-on and some further add-ons for the outside reference. So there might be some slight differences to the A320 by Tu Darmstadt in the simulator there, which is in regards to buttons which are in place here, like for example the overhead panel, which is more or less fully operational in my simulator, and it's just down to very limited functions in the simulator in Darmstadt, but that is actually not important to us because we don't use it that much today. It's also true for some buttons and switches down here. I have some external buttons, so you won't see the mouse moving all the time, but you can see the movement of the buttons. For example, if I switch the parking brake, which is down here, I can turn it with my switch, so it turns in the simulator too. It's also true for the database. I'm running an actual database for simulator purposes in my simulator, so the naming convention of the departure route and some fixes might be different from the one you'll have on the sheets for the simulator prepared. So in any way, the manual and the guidance in the simulator Darmstadt is the governing one for you, so that's the one you should use. So we start in the state of this aircraft, which is basically the engines are running, parking brake is set. We are in Frankfurt. Spot some landmarks here with the old hangars, the terminal over here, the air traffic control tower. Actually no clouds today, which is the actual weather also outside if you look outside the window, and we're standing on runway 07, which is also correct. To give you a better view of the things I'm doing, I'm taking parts of the panels out to have a larger view on those, which is the FMGC, the engine warning display, the system display, the primary flight display, and the navigation display. The state you enter the simulator should be roughly like this. The engines are running. You can see the engines turning here at idle power. Exhaust gas temperature is present. The inner shaft is turning also. We got a fuel flow. We got some status messages. Wheels are down and green. So everything's looking good. And it's warm outside actually. It's 29 degrees today. On the FMGC, we start on the init page. I clear the message down here, the GPS primary message on the clear function, and he's asking me to initialize weights and so on. So we're flying from Frankfurt, EDDF to with a /EDDF. All data is entered in the scratch pad down here, and with the line select key, the 6 ones on the right here and the 6 ones on the left can be entered into the adjacent fields. The flight number is irrelevant. You can think of anything. We take to the TUD007. The cost index is a factor between fuel cost and time-based cost. I just put 25 as a random number in here. Flight level today will be 5,000 feet, 50. The ground temperature is already taken from my weather model. In your case, I think you're operating with standard temperature. Top right indicates here there is an option to go left or right on secondary pages. So the button click to the right, we switch to the right. And I enter the weight data here. The total weight of the aircraft is 65.3 tons. So 65.1 or 2 right now. So I enter 61 tons and zero fuel weight CG of 30. The exact numbers don't really matter. It's for calculation purposes. And we're in the 60 range somewhere between 60 and 62 tons. this should be enough for the moment. We take a runway on the flight plan page. We depart out of runway 07 center. All lateral changes are on the left-hand side of the flight plan page. So I choose here the left-hand side, departure, take 7 center, and then we take the Sobra 5 Delta, which is 7 Delta. Hasn't changed much. Should be the same. Tempe, insert temporary flight plan. I can see already here on the nav display the display of the departure route, so we're departing to the east and then turn to the south. I can change on the flight control unit, on the EFIS control panel here, the range. That is wrong direction. So now we can see the different radiuses here, 10 miles and 20 miles. So you see the departure is leading us to the west as we're departing into direction 070, which is 70 degrees, so it's almost eastern direction. We insert the route here. We simply insert. Now we have a departure route, and the destination is the lowest line in this view, in this page. We take also the lateral revision page, choose an arrival, and take an arrival to ILS 7 center, the Zulu ILS, and now it's offering arrival routes. We skip this step, we just enter the ILS only, and that's about it. In the simulator it might be just a 7 center without any Charlie or without any Zulu or anything else behind it. So we got the FMS data inserted, we got the departure runway, arrival runway. Now we do enter the performance data. Performance data is giving us the decision speed, the rotation speed, and the V2 speed for minimum safe climb. Today I've pre-calculated those values will be 148, 150, and 151. This is data I calculated on my computing device. It's a full chapter of topics again, how to get these values. I don't know I can't recall the flex temperature. I think it was 50. Might be something like that. I'll check this one. Nevertheless, you can take the data for the wheel speeds and also for the flex temperature and the config setting, which will be typically 1 from the handout you receive for simulator. On the RadNav page, we can set radio aids. In this case, it's the approach ILS already set in here, automatically tuned with smaller uppercase letter. Here are 2 radios tuned. It's a very special one close to Cologne. I don't know why it's chosen this one. However, we take the Frankfurt VOR station, which is coded by the letters FFM and entered in the top left side here. There are actually 2 radio stations, 2 VR stations with the coding FFM. So we take the top one with 4 nautical miles distance, not the other one with 4,193 miles different distance, which is somewhere 96 west, probably in the US. The frequency is automatic tuned, 114.2, and now we can set the switch here to VOR and give indication now with an automatically tuned FFM VOR in a distance of 4.1 miles. And it's also depicted here just straight ahead in the forest next to the highway A3 it's located. From the data on our charts, we can choose or take the altitude we're climbing to, which is today I pick 5,000 feet. It might be 4,000 or 5,000, I don't know the exact value, but I take 5,000. So we have the altitude inserted. We do have a lateral flight plan, how to proceed. We do have a radio aid, just in case for situational awareness. So all data is now fed into the system. And we're ready to go. I'll take out for the moment the FMGC. It's of no need at the moment. I take out the system page. It's actually fully operational. I can apply some inputs on my side stick. You can see the ailerons moving, flight controls coming out. So everything is operational. Also the rudder pedal is moving. You can see on the FO side, on the right hand side, how I can steer the rudder and also ride the brakes. So everything is set up. On the system page here we have the on the engine warning display we have the takeoff checklist. It's an automatic checklist triggered after a while. Otherwise you can trigger it with the takeoff config test button. However, we're still not in the correct configuration. So the system asks us to set the auto brake to max, which is a switch here, to arm the spoilers. They are down here. They run, they're armed. Flaps into takeoff config, which is flap position 1. And then the takeoff config test once more. Too fast. Now the status of the flaps is green here. Now I can do the takeoff config test. Everything is right. The only warning I get here is the predictive wind shear system off message, so I can turn the predictive wind shear system on. Now the PWS scan is on the nav display, and just for purposes of normal operation to me, I changed the display on the nav display to the arc mode, which is the most common way for me. With the top buttons here, you can choose for additional options. I take the constraint function here, which is displaying constraints for me. You can also display some terrain information. I don't know whether it's working or not. Looks like so. You can see the Taunus Mountains up here. If I change the range, you can see the Feldberg here and other elevations around me. So now we should be ready. We have our clearance. We are ready to go. For the takeoff run, we set takeoff thrust and then we'll depart. After departure, which is quite some quick movements, I select the landing gear up. I'll turn on the autopilot to have better controllability, because it's with a home simulator it's not such a good controllability as in the actual aircraft. And well, yeah, I've missed out one step. At the rotation speed of 150 knots today, we will lift the nose and depart. So everything is set. I release the parking brake. And we are ready to go. We can maybe start the chrono, which is not necessary, but we'll just thrust a little bit to check the spool up, which should be quite identical in the simulator. Acceleration starts, and I'm applying more thrust. But the FMA on the PFD has changed to manual thrust. It should be flexi thrust, SAS on the runway. So accelerating, steering with the pedals right now. We're approaching the V-speeds, and I'm lifting the nose slowly, aiming for 12.5 degrees in pitch. Gear comes up, and the autopilot comes on. Autopilot on is active now here. And then flex 50. We're in the acceleration phase. There's an acceleration altitude coded already in the FMS. Once we pass the altitude, it is now Switching to climb mode, asking me to adjust the thrust to climb thrust. Now, there we go. Thrust climb. Climb Alt blue. The next vertical mode is armed. So reaching our 5,000 feet of altitude here, the aircraft will level off. We're climbing 1,600 feet per minute rate of climb, accelerating a little bit. This is the S speed, the minimum speed to protect the flaps, or to fly with flaps extended. We are passing this, we're approaching the next turn in 2 miles only. Now we're above airspeed and we retract the flaps. Green dot has now become active, so this is the minimum maneuvering speed for clean configuration. Speed is 220, that's a requirement of the departure route for the first turn. Rate of climb is high, so 4,000 feet passing. Alt capture mode, the star mode, is now active. Thrust is starting to reduce. You can see it here on the engine display because we're approaching the altitude. And the aircraft starts to bank, starts to turn with right turn on the departure route. And the message here where the ground spoilers armed. TCAS stand by. I forgot the TCAS. So let's switch on the TCAS, which is there we go. This auto and the spoilers are armed. Disarm the spoilers. Now we're cruising at 5,000 feet, very stable altitude. Still accelerating. Now we've passed, looks like we've passed the first speed limit, however there's a speed constraint still 220 knots, so this is a failure in the simulator. The speed constraint is still applicable because we're on the way towards Delta Fox 150 and this aircraft has accelerated to 250 knots, which is not appropriate. So what do? The pilot can act, so if something goes as beyond expectation or not as intended, I can pull and have a selected speed of 220 knots as required by the procedure. So if there's automation doing something wrong, for whatever reason it is, there is an obligation for the pilot to act. Thrust is reduced, aircraft is decelerating towards 220 knots. And reaching 220 knots, we have a thrust increase to maintain 220 knots. Now we're turning to the south. Change the range on the nav display. You can see here on the right hand side the double white stripes, which is on the runway for landing, and basically that's the direction we want to go. So as with a flight management system, we can also select a lateral deviation. So we pull the heading back, the mode has switched to heading. The present heading is the heading which is taken, and we turn this one towards a heading of, let's say, 250, back towards the approach. So the aircraft is turned and it's following my command. The navigational guidance we have in the FMS is still displayed, but with a dashed line only because it's not active. Active is the heading mode. For approach, the FMS wants to know some things for calculation purposes and to destination data we are asked. So we go to the performance page, go to cruise phase, next phase is descent, next phase is approach. The QNH, the local air pressure, is inserted, the present temperature, and the wind, which is almost 0, I think. So we'll just make some number. We can also insert a minimum which is also by heart now. I've just picked some number to have something inserted, and you'll receive information on this one also. Okay, what's happening outside? Get some changes in the vertical speed, so there might be some thermals, some movement of the air going up and down. Air traffic control might instruct us to go direct this point here, which is Delta Fox 201 for some reason. So we can at any time set Delta Fox 20 as the active waypoint. We will push direct, choose the correct waypoint. Now we gotta display how the routing will be changed with a yellow lateral trajectory. If this is according to our thoughts, what we imagined, our mental picture, we can insert it, and nav mode becomes active. On the right hand side, you can see already the approach. With the final fix, this has changed. In your charts, the final descent point has a name, but unfortunately, they got rid of it, so we got these 2 points here at 4,000 feet, which are the points of the ILS, and Delta Fox 560 is in descent. For the approach, we have the data inserted. We are still going 220 knots, which is fine for the moment. We want to have the, sorry about the movement, the ILS displayed, so we want to see the guidance which we are following, and with the LS button up here we can switch on the guidance system. Automatically tuned is the ILS frequency down here, and the distance is, you can see here. Let's see if we can hear the island also. To me, it sounds approximately correct. I think the F wasn't done in the correct way, but well, for a simulator, it should be okay. So, we don't want to continue on the departure route. We want to join the final approach. So, on the one hand side, we can either just turn by heading, but unfortunately, the departure route is still active. To have all the advantages of the aircraft, for example, if we are going around having a missed approach and want to join the missed approach procedure, we have to have the correct waypoint sequencing. So the points of the arrival runway should be the active waypoints. And we can do this if we go on a heading. Just take the present heading and set it direct towards, let's try here, towards the final descent waypoint with a radial inbound. And now you can see here, we have an extended center line of the approach. This is just an extended line beyond Delta Fox 560. And if I insert this one, everything else is taken out. Delta Fox 560 is my two-way point, and I got this extended center line. I got nav in blue armed here. So if I turn on any heading which has an intersection, a crossing with extended center line, it would automatically compute a turn inbound the fix. But as I'm following commands from air traffic controllers, I just pull heading once more, and the armed mode vanishes, so I'm now free to turn any direction. Distance towards the point is 11 miles, which is quite okay, so we turn now to the right and turn right. Typical intercepts are on a heading of about 040, so 30 degrees off from the center line direction. I get a localizer indication on the PFD down here, which is good. But everything is looking good. Not everything. We're still at 5,000 feet. The approach is starting here out of 4,000. So we want to descend 4,000 feet first. I sit here, the altitude to 4,000 feet, and now this time I pull vertical speed and set a descent rate of, let's say, 1,100 feet per minute. Right now I'm seeing that my heading isn't so good. I run a rollout on heading 340. That's why I'm not a professional air traffic controller. They can do it much better. My original heading of 040 would have led us to a descent or to an intercept with a localizer course beyond Delta Fox 560, which isn't a good idea at this time. So we'll fly a little bit more towards the center line. Now we're 5 miles off. I can see the heading inbound here. And now we're coming a little closer towards 040. On the FMS, in the meantime, you can activate the approach phase. The approach phase gives us automatic speed reductions as soon as we are in managed mode. Now we're at 4,000 feet. Still good. Heading inbound or course inbound Delta Fox 560 would be 43, 44, and increasing. So if I turn right now, this direction, on a heading of 040, we got the perfect intercept heading. However, we don't have enough intercept anymore. I've deselected enough intercept, and that's for a good reason, because we don't want to navigate inbound to the Delta Fox 560 point, but follow the ILS with the localizer guidance and the glide slope guidance. So I push the approach push button here on the FCU, which arms the motors. For commonality reasons, I always activate the second autopilot, which is not required today because we have perfect weather outside. We can see the airport already. We have the glide slope mode activated here, not activated but armed here, the localizer mode armed here. And we got three duals, so we could land at a ceiling, a cloud ceiling of 0 feet, so we can see only the runway after landing. Lock star comes active because the localizer is approaching. In the distance you can see already the airport. Still at 220 knots, we are below flap extension speed. So I start with the speed reduction first, to overload the flaps and give a little relief on those, and start with the flap extension. Conferring to flaps 1, you can see now the target of the slats and the slats extending. I select further down to 180 knots, which is a good speed. We're passing the next VFE speed, 200 knots, and select flaps 2. Flaps 2 is slats at position 2 and flaps extending also to position 2. And this is the good position with enough drag for the approach. Just a little bit the view so you can see the airport outside. The glide slope is coming in. We're approaching the descent point. That is a correct indication, so I'm expecting to have the glide slope here at this point. If it's not, there might be some other reasons due to wrong altimeter setting or other things. Temperature outside. Glide slope is captured. The star mode is active. The aircraft is leaving the assigned altitude, and it's the only mode where the aircraft automatically leaves an altitude. And it's following the glide path and the localizer down to the runway. So now comes the big question whether we continue like this or if we fly manually, depending on your self-esteem and your current state, how you like everything done. You can choose one of those. So either deactivate the autopilot or have the autopilot land the aircraft. In this case, I'll leave the landing up to the autopilot because simulator landings on a home simulator are always much worse than actual landings. So I'll leave it up to the autopilot. We're at 3,200 feet, 100 feet now. Airport elevation is at 360 feet roughly. So 3,000 feet, a little less to go. For the go round, the altitude is 5,000 feet. I said 5,000 feet here just in case. 2,500 feet and downwards, the radio altimeter indication becomes alive. The radio altimeter is already operating all the time. Also at higher altitudes, but passing 2,500 feet, the indication comes alive. And as we're coming closer, it's time to decelerate. I select the managed mode again. The speed target is now reduced to the approach speed later on, 139 knots. Power setting is idle, and we select gear down to increase drag because we're quite heavy today, and the gear down anyhow. We select further flaps 3. And flaps full. We have to arm the spoilers. There we go. And select auto brake is low. Passing 1,200 feet above ground. Coming into the acceptable establishment, the stabilization criteria, which is approach speed +10. The landing checklist is all green. Cabin ready is received, so we're good to go, good to land.
1,000.
We can see the PAP precision approach path indicators, white and red, which is the correct setting. 2 white, 2 red. Upon landing, I will select reverse thrust just to support the brakes, to have the brake temperatures not as high as possible. And take some note of those. Try to have it in the idle reverse range only, but obviously. Turn the sound
500.
To get the retard.
400.
Auto callouts come active. The land
300.
is here.
100 above. 200. Minimum.
These parties are correct. These ones
100.
are not. I don't know if these are.
50. 40. 30. 20. 10. Retard.
Reverse thrust. Automatic spoiler deployment. And I'm going to the direction of regular reverse. So the auto brake is active, which you can see down here on the other side with the decel light. Spoilers are extended, reverse thrust is working, and we're down to taxi speed. So it's time to deactivate the autopilot, deactivate auto thrust, and to disarm the spoilers. So we have landed, and now we can taxi forward to leave the runway. And while the captain is taxiing to vacate the runway, the FO switches off all systems. should be good. We're parking here on number 5. Our gate is not ready, so we have to stay here anyhow. So parking rack again. So disarm the PWS. Radar off. TCAS off. And we can start the APU on my simulator at least to have a ground power, and we can switch off the engines. So that's up for the moment. I hope you enjoyed it and have some